Good day, students. You are required to divide the polynomial 4x squared minus 13x minus 5 by s minus 2 using the method of synthetic division. So, synthetic division, as we know, is when we are given a factor. In this case, if your factor is s minus k, is a factor of f of x. In this case, f of x is the polynomial 4x squared minus 13x minus 5. Then in that case, s is equals to k. So by synthetic division, we have to know that a synthetic division involves arranging the coefficients of each of the terms of the polynomial, which we also include we include the terms of x that has no in which its coefficients is equals to 0. So I say that by synthetic division, we divide polynomial by binomial of the form. So in this case, there are steps you have to follow in order to achieve this aim. So the first thing is to write the coefficients of the dividend in order of descending exponents, including a 0 for the a value of x terms that has no has its coefficients is equals to 0. In this case, let's write the coefficients 4, minus 13, and minus 5. We do not have a term here in which the coefficients is equals to 0, since the highest power of s here is 2, the second is 1, and the coefficient is 0. So you write it. This is the first example. Then when you have done that, you place the divisor in the left uppermost column. So here, since s is equals to k, in this case s minus 2 is equals to 0, and that gives us s is equals to 2. S is equals to 2. So the divisor is 2. So this is a polynomial. This s minus k is what in a polynomial form, and this one is in s minus k is in the binomial form, which is the divisor, and the polynomial in which we have to divide. So in order to apply synthetic method, we have to write the coefficients synthetic division method. So we have to write the coefficients of the dividend. Dividend is the polynomials in order of descending exponents, including a term of x that has no in which the coefficients is equals to 0. So once we have done that, the next step is to bring down the leading coefficients. If you look at this leading coefficients here, which is 4, you bring it down. So once you have bring it down, the next thing you have to do is you have to multiply the leading coefficients by the k value. Multiply the leading coefficients by the k value. In this case, the leading coefficients is 4, so multiply 4 by the k value, which is x. S is equals to k, and k is equals to 2. So you have what? 8. Once you have gotten the 8, the next step is to write down the product under the second coefficients. This is the product. You write it down here under the second coefficients. Then the next step is to multiply. Once you have done that, you add the two terms. Add the 2. That is minus 13 plus 8. You add the 2. Once you multiply, bring the leading coefficients down and multiply by the k value, and then whatever you got, then you write it down under the second coefficients of the polynomial and add up the result. That is minus 13 plus 8 will give us minus 5. Then once you have done that, you have to multiply the previous sum by the k value. So you have to repeat it, which means minus 5 times 2, and that gives us minus 10. So once you have gotten the minus 10, you bring it down here under the next coefficients, and then add up the 2, that gives us minus 15. So this process will be continued. You can repeat this process for the remaining coefficients. If you have another values here, you have to continue to repeat it in that form, multiplying by the value of k to the sum of the previous you got, the sum of the previous result you got. In this case, like I said, you bring down the leading coefficients, that's the first thing. You multiply it by 2, add the result under the second value of the coefficients. Value of the coefficients that make up the polynomial, they add up. Adding up means sum. So when you add up whatever you got, you multiply it by 2, put it down under the next coefficients of the coefficients that make up the polynomial, and add up. So once you arrive at this form, you stop. So now you can now write the polynomial in this form. So from here we can conclude that f of x, this polynomial divided by the divisor, we all know is equals to quotient plus what? The remainder divided by the divisor. So at this point we can now do what? We can now substitute these values. So from here we know that the polynomial is, this is the polynomial 4x squared minus 13x minus 5 divided by s minus 2 is equals to the quotient. In this case, step 4, look at step 4. The highest degree of the leading term in the quotient must be 1 less than the highest degree of the f of x. The highest degree here of x must be 1 less than the highest degree of the polynomial based on the result you got. So from here you have 4x, remember this is 2, so this will be 1, which is 4x. That is 2 minus 1. 2 minus 1 will give us 1, and s raised to power 1 is still x. So because any number or variable raised to power 1 is still the variable or number, so 4x minus 5, this is the quotient. Step 5, when you complete this synthetic, the last value you got here is the remainder. The last number is the remainder. So when you are solving it and you got the last number here, after you must add the previous result with the coefficients of the last term. Whatever you got here or you get here is the remainder. So in this case, plus minus the remainder divided by the divisor. So in this case, the divisor here is s minus 2. S minus 2. And we know that plus minus is equals to minus. So you can remove here and then put minus here. And that is the result. So that is the result of the divisor. So s minus is equals to minus, so that is it. So when you divide this polynomial by s minus 2, the result is equals to 4s minus 5 minus 15 divided by s minus 2. So can we do another example for clarification? This method of division, or this method of dividing a polynomial by a binomial expression, this only works when it is a binomial expression in a linear form, in this form, not s raised to power 2, not what? S raised to power 2. This is a binomial form expression, s minus 2 in this form, and the x plus or minus k, that is in this form. a factor. So if s minus k is a factor of f of x, then s is equals to k. Then s minus k is equals to 1. We have done that. If s minus k is a factor of a given function, then s minus k is equals to 0. So that when k going to the other side of the equation, we have s to be equals to k. That is how we get the divisor. So in this case, this is the k value, and then you apply the syntactic method. So let us look at another example for clarification, so that you'll be able to do it when you see anyone. Let's clean here. So the second example is, we are given s to the power of 4. S to the power of 4 plus 4 multiplying x to the power of 3 plus 16x minus 35. That is, we are given s to the power of 4 plus 4s raised to the power 3 plus 16x minus 35 divided by s plus 5 using a syntactic method. Use what? Syntactic method to do it. So we know we also have long division method. So, but this is for you to know how to make use of syntactic method. The first thing is to put it in this form. So look at the coefficients of the terms that make up the given polynomial. This is the polynomial of f of x divided by the divisor. So in order to use synthetic method, you have to look at the divisor and see if it follows the linear binomial expression. Actually, it follows it. So this means that if this is a factor of this polynomial, then s plus 5 must be equals to 0, so that x is equals to minus 5. So minus 5 you put here based on the steps I listed before. You use to solve synthetic method of division. So the next is to list the coefficients of the terms that make up the polynomial in order of magnitude, or in descending order of magnitude. Here we have s raised to the power 4, so the coefficient here is 1. The next coefficient of here is 4. Remember, you are told that this listing of the coefficients of the terms that make up the s term that make up the polynomial must include the terms which is missing term. In this case, if you look at this setup here, you notice that we don't have a term in plus a term s squared. So the reason is because the coefficient is 0, and we know that when we are solving mathematics, when we multiply 0 to any number and we have 0, if it's an algebraic expression, we always omit that term. So that's why here we have to include 0 here. You must include the terms that are not included, that form of the polynomial in which the coefficient is equals to 0. So in this case, s squared, the coefficient is equals to 0. I include it before I can now write the next one, 16. Because the highest power is 4, you must include all the powers that make up the terms up to the list in order of magnitude, descending order of magnitude. Here we have 4, 3, the next is 2, and there is no 2 here. We notice that the coefficient is 0, and then the next is 1, x, before you include when s is 0, in this case minus 35. So once we have done that, the next step is, we are told the next is to bring the leading coefficients down. The leading coefficients here is 1. You bring it down, and once you bring it down, the next thing you have to do is to you multiply it by the k value. You do what? You multiply it by the k value. In this case, 1 times minus 5 will give us minus 5. So whatever you got, write it down to the next column of the next coefficients that make up the f of x function. So once you have done that, the next thing is to add up the result. Add up the result you got. So in this case, 4 plus minus 5, plus minus is minus, so 4 minus 5 will give us minus 1. So you write minus 1 down. The next thing you have to do is to, whatever you got, is it not minus 1? Then you have to multiply it by minus 5. You have to multiply it by minus 5. That is the k value. So minus 1. So minus 1 multiplying by minus 5. Minus minus is plus, so 1 times 5 is 5, plus 5. Then once you get plus 5, you write it down here to the next column, down to the next coefficients. That is when we have s squared, 0 coefficients of s squared. Write it down under it. So once you do that, you sum up the value. That is 0 plus 5 will give us what? 5. So you write 5. You have to repeat the process again. To repeat the process, in this case, you multiply minus 5 times 5, and that gives us minus 25. So you write here minus 25 and sum up the result. 16 plus minus 25. 16 plus minus 25 is what? Plus minus is the same as minus, so 16 minus 25 will give us what? That will give us minus 9. So you write minus 9 here. So you have to perform the operation again. You have to perform the operation again. So the next thing is to now you get minus 5 minus 9. So you have to minus 9 times minus 5. Multiply whatever you get by the k value. Minus minus is plus, so 9 times 5 will give us plus 45. Then you write 45 here. So once you have done that, the next thing you have to do is to sum up the values. So minus 35 plus 45. That will give us what? Minus 45, minus 35 plus 45 will give us plus 10. So you write 10 here. You are through with it. So the next thing is to write the value of the result you got. So in this case, we have that s raised to the power 4 plus 4s raised to the power 3 plus 16x minus 35 divided by s plus 5. So what the result? S raised to the power 4 plus 4 multiplying s raised to the power 3 plus 16x minus 35 divided by s plus 5. I told you that once you got the quotient, the value of the quotient in this case, the value of the quotient in this case, the value of the quotient in this case is always 1 less than the power of the the power of the quotient, the highest leading power of the quotient is always 1 less than the power of the f of x. So you start by, since the coefficient is 1, so you start by x. We don't write the 1 here. So if you want to, you can write it for you to know that is 1. Then s raised to the power 4 minus 1. And s raised to power 4 minus 1 will give us what? S raised to power 3. So in all of this, we have x raised to power 3 minus, you know, the coefficient is 1, so you don't need to write it. So minus x raised to power 2. You have to write them in order of descending order of magnitude. So here is plus 5 raised to power plus 5 multiplying s, since you have already written s raised to power 2. So the next is plus 5, the coefficients multiplying what? X. It is in decreasing order of 1. Each of the powers of x is decreasing by 1. So the next will be what? So the next will be minus 9. So this, I told you that the last term here is always the remainder. So minus 9. Once you have done that, minus 9 plus, because this is 10, plus 10 divided by, plus 10 divided by the divisor s plus 5. So that is it. Or you can write it below here so you can know that it is not just a divisor of all of this. So let's write it here. This value here, this is equals to s raised to power 3 minus s squared plus 5x minus 9 plus what? 10 divided by s plus 5. So that is it. So that is the answer. If you have been following up to this extent, I believe you already know how to perform division using synthetic method. So before we close for today, you will do this one for me, so be able to know you already understand how to use synthetic method. So do this one. S raised to power 4 minus 5s raised to power 3 raised to power 3 minus 8s squared plus 13x minus 12 divided by s minus 6. We are asked to use synthetic method. So do it. I hope if you enjoyed this lesson, please, before you go, do me one favor. Click the subscribe button to encourage me to bring more videos for your view. Like and share. Click the notification button whenever there is new update. You'll be the first person to receive the text. Please, you can as well go to our website at www.manzananews.com/ebook and then download books in this area of polynomial. You can as well buy courses in polynomial functions, expressions, and equation. So I hope you enjoyed this lesson. See you in the next lesson. Bye for now.